Assalamualaikum warahmatullahi wabarakatuh. Good day everyone. My name is Fatimah Naya R and I'm from Group 1. And today we're going to present our final project for Electronic Instrumentation Design course entitled IoT-Based Environmental Monitoring and Device Control System for Bedrooms. And of course, I'm not going to be alone. I have Alvin Muliawan and Vieri Abdi as my partner in this group. First is I'm going to walk you through the introduction for our project. In an era where the Internet of Things or IoT has become an integral part of our daily lives, its application in home automation and environmental control systems is increasingly significant. The primary goal of this project is to design the implement an IoT-based environmental monitoring and device control system for bedrooms. The project centers around the development of a printed circuit board or PCB using KiCad software to create a cohesive and efficient platform. This platform will enable real-time monitoring of environmental parameters within bedroom, such as temperature, humidity, and air quality. Next is the method where we utilize KiCad. The project utilizes KiCad, a robust and versatile PCB design software, to create a custom board that integrates sensors for environmental monitoring and actuators for device control. The design will involve selecting appropriate sensors, microcontrollers, and communication modules to ensure seamless connectivity within the IoT ecosystem. The use of KiCad is pivotal in optimizing the layout and connections on the PCB, ensuring reliability and efficiency in the hardware implementation.
So this is the schematic for our project. First, on the top left of the schematic, we have the relay module. Here we use two pieces of one channel relay module, and the function of this relay module is to allow the actual lamp to be controlled with our system. Next, we have the output LED below. So actually, we can use an actual lamp, but for easy prototyping, we use an LED output because it's easier to prototype. Next, below we have the GPIO pin, and this GPIO pin allows versatile connectivity and interaction with external devices or sensors, and it also enhances the board's flexibility in accommodating additional functionalities. Next, we have the USB-B port, and this is used to connect the ESP32 to the computer so we can upload the code. Actually, we can also use the USB-C, but in here our group chose to use the USB-B port because it is easier to solder into the PCB. Next, we have the ESP, which serves as the main microcontroller here, and by using the ESP, we can control our project from our mobile phone through mobile apps. The ESP we use is the ESP32 C3WROOM02. Next, we have the push buttons, and this allows for manual control for user interaction and allows on-demand operation or overrides. This enhances the user's ability to manually trigger specific functions. We also place several mounting holes, and this is used for easy installation and secure placement of the PCB board within the designated environment, and this ensures stability and reliability. Here we use also the DHT sensor, and this DHT sensor provides real-time data on the temperature as well as the humidity level in the bedroom, so we can always monitor the condition in our bedroom. Lastly, we have the components for power supply. We have the power indicator, power input, power select, and so on. Next, this is the view of the PCB in the PCB editor. This is where we placed our components, and we ensure that there are no components overlapping and there are no wires overlapping. To make it easier, we use two layers in the PCB. The first is the red layer, and second is the blue layer. This is the view of our PCB in 3D view. This is more or less the more realistic illustration of the PCB. And here we can see that the components are placed well and there are no components that overlaps each other. And we make sure that the spacing between each component is suitable, so there are no errors, hopefully.
Okay, next is the conclusion. So our PCB board represent a sophisticated yet user-friendly solution, combining hardware components with IoT capabilities to create a smart and adaptive system for bedroom environments. This design allows for customization and expansion, thanks to the GPIO pins, enabling potential future enhancement or the addition of new features. The integration of the ESP module ensures connectivity to the broader IoT network, enabling users to remotely monitor and control their bedroom environment through smart home application or platform. So this is the suggestions for future enhancement and application. When considering the significance and the potential impact as well as the future work, for the entire PCB design for environmental monitoring and device control, we can look at the system holistically. So the first one is future version could include more diverse sensors such as CO2, particulate matter, or VOC sensor to broaden the environment monitoring capabilities. The second one is to developing a user-friendly interface, potentially through a mobile app or a web dashboard, would make it easier to visualize data and control devices remotely. And then the third one is optimizing the PCB design for easier manufacturing and assembly, such as reducing the number of layers or using surface mount technology to streamline production. So this is the end of our presentation. Thank you for watching and listening. Wassalamualaikum warahmatullahi wabarakatuh.